Good morning, guys. Welcome back to another reading/video session. Last week we talked about database and the basics of what a database is. And this week we're gonna cover database again, but this time it's not the same info, right? It's a continuation of last week's topic and session, going more in depth into database objects this time. So you should be able to define what a database is now, what a database management system is, and why we use databases. For this week, we'll cover what we call database objects. And database objects are basically entities that we use in any database or any given database. Objects are really just a better word to use than calling them things. Like you won't say, all right, we have database things here. Sounds kind of foolish, sound kind of dumb. But for all intents and purposes, we call these things objects. And objects can refer to all kinds of entities, or I'll use the word things, that holds the data in a database system or allows us to manipulate the data in some way. So we call these things objects instead of just things. And these objects can be, some examples of these objects are what you see here in this image. These are your basic objects that most people use on database systems often. And you have your table, which is at the top of the image here. Is probably there for a reason, because you need tables to have your data be stored in a database. That's how the data is configured, and we covered that last week. And from these tables, you can generate, or you can use the other objects which manipulate the tables, or query or draw information from the table. So let's begin with the first object, which is the table itself. In a table, the amount of data that can be held in it is dependent on the administrator or the user that created the table. The reason why I say it's dependent on them is because they decide what type of information is going to be stored. For example, you have two sub-objects or two things that make up what a table is, and those are columns and rows. For your columns in a database, these are your vertical sets of data, and these hold specific types of data, meaning you, again, or the administrator, decides, well, I'm gonna make this column to hold dates, and I'm gonna call it date. The next column over, you can say, well, I'm gonna make this column hold numbers. Why is that? Because this column will be called student ID, for example, and you only want numbers there. If you need to store something that's larger than a number, like a name, then you go to the column over and say, well, I'll call this column name. And that's when you have textual data. That's why I say the amount of data depends on you, because you're telling me or telling the database how much data you're going to be using. Numbers or textual data. Textual data usually needs more space than numbers. Why do we need textual data? That's why it depends on us. Do we need to save a person's name? If yes, then we'll need to put a column for textual data. Let's see if I can showcase it real quick, but that's basically what we're going for there. So this is your database, accessing through Microsoft Access. We have an ID by default. If you want to add another column, you click to add, and in this case, this is what I'm saying. These are the data types that you can add. Will it be a text? Sure, let's choose text. What are we gonna call it? Let's just call that first name. Do we add a next one? Sure. What do we want to call it? Let's put a number. What number do you want to give this person? Let's call this school ID, and so forth and so forth. If you want to add more, you go ahead. Alright, so those are columns. The vertical rows are your columns. Then we have rows. Rows are the horizontal sets, and they are called records as well because they define one set of information that belongs to one specific item or person. If this is me, my school ID is 123. This row here is one person in this case, which is myself, and it's a record because it's just like in English. If it's a record of someone, it has their name, it has their information. In this case, my information is my school ID. If I wanted to add more information, I would have to configure a column, let's say a short text, and we'll put address, and then this record will now also hold my address if I had it incorporated, right? So that's why we call those records or rows, because they have one set of information. So notice the dynamic here. This is a row, that's a record for me. This is a column, and that's the type of information, right? One column can't tell you everything about a person, but it will tell you what type of information it is. So this is the first name, so I know that's a text type of information. What does this show? My first name. And whosoever first name that will be added will be here founded. School ID, well, it only shows school ID, tells you what it is. The rows tell you who it is, but only on a one-by-one basis, right? One person, another person. So this, right? So that's another person, another person. So please remember that records are one item, but it's a set of info for that one item or person. Columns are the specific types of data and tells you what they are. Right? Then you have a cell, which is basically just one single entry of your database. So it's either one box here, that's John, that's a cell, but you don't really need to go too in depth with that. I just wanted you guys to know what it is. So now we talk about queries. Queries are how you can request information from the table. These queries are built and they have to be programmed or created by database administrators. Queries usually run in a database client, which is a way for you to communicate with the database as well. Microsoft Access allows us to perform many of the features that a database client has, such as being able to write queries and run them, and basically communicate with the database, especially if the database is stored online or on a server that's far away from where you are. You'd use a database client, which is a software or a program on your computer to be able to access the server where the database is located. So you can be home and your database can be at your company or workplace that might be 100 miles away, but you can remotely access your database using a client, getting the IP of your database, having some VPN so that you can access it, stuff like that. We don't have to get too in detail with that, but it's known that the database client allows you to retrieve information and manipulate the database in certain ways. Alright, and queries, one of the staples of database, is how you request some of that information. You can request info, you can insert info, you can delete info with queries. It all depends on how the query looks. Here is a very basic query. Query is written in SQL or standard query language, and it's kind of like programming if you think about it, but it doesn't have the same processing involved. the language itself is its own language, and the way how it works is you have to use keywords just like in programming. The keyword select means exactly how it sounds, select or choose, and then you follow the keyword select with the names of the columns. So it's telling you, or this query is saying, select the column's first name and the column last name. Then you have the keyword from, which tells you, alright, from where? From the table, and the from is followed by the table called customers. So let's put it in English. Select the column first name and the column last name from the table that's called customers. So that's our query to select or to choose the information. Then last week we talked about constraints or limitations. You can easily just run these two lines just like that. Select first name and last name from customers, and it's going to give you the first name and the last name of all customers in your table. Remember, we don't want that for this case because that's too much info. So we start constraints by using this special word keyword where. So it says select this, but it doesn't say but here, but that's what we're saying in English. But I want the ID in, and then it goes and does a subquery in brackets, but you don't have to worry about that. I'll just describe it. It's telling you to look in the table called cars purchased, right? Because we're still following the same explanation. Select the customer ID from the table cars purchased. So we have a table where they purchased cars before, and the color is red. So from this subquery, we can see that they're selecting another table where people have purchased cars, and that's where they store that info, and they just want the customer ID from that table. And if the ID of this customer is in that table and they purchased a red car, then that's what we want. Alright, so in English, give me the first name and last names of the customers table where they have purchased a red car. And, well, this is compound. This is a compound query, or a compound constraint that's asking for also blue, pretty much. So this is what you see in some queries. This is a more advanced one. This is just one that I could find where the text looked clear, so I just chose this one. I didn't realize this was a compound one, or one that has a select or another query within the query, but that's what it does. Alright, I don't really want you to understand exactly what this query means. Just know that that's how it looks, and at least learn that what select does and from does. At least those two. Select, give it the columns that you want selected, first name, last name, and then from is followed by the name of the table. So from, and then you tell them which table is this information from that you want. Well, it's from the table customers. Alright, so it's a lot of thought that needs to go into queries, because you need to know exactly what you want, and then you use those constraints to get that information. And then a takeaway here is that notice they want info from one table, but then they're also querying a second table, and that's where these relations start getting built. So we'll get to that in a minute. So that was that query, a kind of more advanced one for you guys, but pretty sure you understand a little bit what it was trying to do, right? Based on my explanation. Basically, they're just trying to get the customers that bought red cars and blue cars. Well, why doesn't it look more simple than that? Well, it's not that simple, and I'll just leave that there. The second object that we're going to cover are forms, and it's just like Google Forms basically. A form is a form. You use it to enter data. We have to fill out forms in real life when we go and register, when we go and apply for sixth form. We fill out these forms, right? Name, school, and whatnot. Forms are there, and they exist to collect information, and that's pretty much the main point. So you can do forms in Access, and the point of forms in Access is so that you can just enter quickly what needs to be collected, and it will enter that information into the database using the form. Why do we have forms? Because do you really want to be writing a query every time you want to insert one row of information? Some database tables are long. They can have name, first name, last name, social security, student ID, color of house, address, phone number 2, email. Again, do you want to write a query that's that long, or do you want to just fill out a form like this one, click enter, and then all of this will get put into that table for you? So that's why we have forms. It's easier to collect information that way, but also it includes the information that the database needs. These fields here are basically the names of the columns of your table. So you can ensure that what you need to put into the table are already provided in the form. There's a first name column, last name column, and you just fill out the form, press enter, and then it's going to populate a record or a row with that information. So forms gives an easier access to enter information, but also it helps to reduce errors or maybe mistakes. For example, if you forgot about one of the columns and you were writing the query, you'd forget to put that information. But if you have your form, you can clearly see that, oh, okay, all the information I need is here, and if one of these spaces are blank, then you know you're missing something. So it helps with that as well. And because tables are predefined, you know what should be on the form. First name, yes. Last name, yes. Address, yes, that's on my table. Good, I'll need those things. So that's the main use of a form, and it helps reduce errors of forgetting or missing out on certain data. Then finally, the last subject that we are going to cover for today in terms of the table and the data is the reports. A report is exactly how it sounds. It's information that is formatted, collected in a concise format, and it's basically the result that you'd get from a query, but then you want to put it in a way that you can print it, or in a way that is meaningful to the people that you're going to hand it to, because reports are usually for the managers or the sales managers or basically other departments of a company, not for the database administrator, because I don't, as a database administrator, if I was one, I don't need to have those reports because I have access to the data pretty much all the time, and I use a query or something to quickly look at the info. But sales managers or sales associates don't have access to the information readily. So you'd want to generate the report for them. You'd include only certain information because you don't want them to have all the information, and you'd print that out. You hand it to them, and then they can use that information to analyze and create their own reports and statistics or so forth. So that's what reports are. There's just more summarized, concise, formatted info that is usually printed or sent to other people in the department. Alright, so we move on to different objects now, but they're not like data focused. They're more related to why we call the databases we're dealing with relational databases. We covered this in class, and I think a lot of you had trouble with this, so we'll go over it again. Those are the primary key and your foreign keys. The primary key is necessary because your database houses millions or thousands depending on your company, but usually it's millions of rows of information, and it is necessary to have something to differentiate each row. Certain things can be the same. For example, someone's name can be the same, someone's address can be the same because people move in and out of places all the time, but we have to have something, and it's just for the integrity of the system, to differentiate one row from the next. And that's why we use the primary key. The primary key is a column, alright? It's just like any other column of data in your table, but it does not allow duplicates on that column. It does not allow you to put the same number, for example here with the student ID, because the database will use that to differentiate among all records. And then if you try to put the same number on that column, it will show an error that says primary key cannot be duplicated. And that's all it really is. It's just a safeguard for your database to be able to distinguish between records. And if the person tries to put in the same ID, it'll say it's duplicated. That's all the primary key really does from like a practical point of view. Clear? Alright. So that's your primary key. Primary key has, actually it's not even the job of the primary key, but it's the foreign key. The second key we're going to cover is the foreign key. So keep that in mind. The primary key basically differentiates all records, and just that you need to know for now. The foreign key are what contributes to the relational part when you say relational databases. Foreign keys are columns, and I'll read it right from the page, are columns that links data between two tables by referencing the primary key of that table. And I drew an illustration below. A foreign key, and let's just break it down real simple. A foreign key is a column as well. It's its own column, and it has information just like all the other columns. The specialty, or the thing that makes it a foreign key, is that the data you include in that column is going to be found, or it references the primary key data of a secondary table. So take a minute to look at the table. In this case, I have a column called major. Why is this column called a foreign key? Is because major has values that can be found in table 2. These values correspond to the ID in this table 2. So we call this column major ID. Notice this column has value 1, 2, or 3, nothing else. In my first table, the major for Ray Liang is 3. If you just look at this table, you'd be like, well, what is 3? 3 doesn't mean anything to me. This is probably a foreign key. So let's look at another table and see if we can find the majors. Well, look, this table has the majors. What was my major? 3. So if it's 3, then what's the name of that major? Well, we have a column to describe the name, and that's science. So that's what it is. The major for Ray Liang is science, and then the major for James Lopez is science as well. The reason why there are relations like this is because text data uses more space than numerical data. And some of you might have been thinking, well, why didn't I just put the major and done? Well, you're using more space here. And also, another reason for separating these things is to something called normalization. And normalization is to make the information easier to analyze and sort using queries. So we're splitting up the information, because if you have a table 1, and let's, instead of calling it table 1, we call it students, then you know that's information that should be for students. But then we need a table to just describe the school majors, because someday we might change the majors or add new majors. So this helps us keep track of the majors, or the different subjects. And then we have a table to keep track of just students. You're separating the roles, or maybe separating the job in a way, because if we didn't have the school majors and we only had it here, let's say something happens to this table, let's say information gets deleted, then you suffer the loss of your student data and even your school major data. But by separating them, you're kind of minimizing the risk. You're allowing for easier methods of analysis and queries. Alright, and then you're also saving some space, because you're using in this case here, you're using numerical data instead of textual data. So you're saving some space than to rewrite another word there. So those are 3 things that I can think of, or benefits of separating your data. So foreign keys again. So it's a column on a table, and what makes it a foreign key is that it references values of another table. Alright, so that's what you have to remember, and this, in this definition here, is what you need to remember. A foreign key links data between 2 tables by referencing the primary key of that table. So it's always going to be referencing the primary key of the second or other table. So one thing to note is a foreign key is just a regular column, and you can have duplicates on your foreign key, right? Remember, the rule is the primary key cannot have duplicates, but a foreign key can. The rule for the foreign key, it just must point to a value that is found on another table. And the second rule is that it has to be the primary key column. So it just makes it easier for you. Is this a foreign key? Ask yourself one question. Does it have values that are found in the primary key column of another table? Yes? Alright, it's a foreign key. It can be duplicated because it is not a primary key. So it can be duplicated. It doesn't need to follow that rule. That's pretty much it. Foreign keys can be found on any table. As long as it follows that rule, it points to another table. It has to point to another table. And what does it have to point to on that table? The table's primary key. I could have had a foreign key right here on this table, but for what reason? Right? You need to have a reason for these things. For me, the reason why I had to have a foreign key in my students table is because I wanted to be able to know what major this student is enrolled in or is taking at the moment. So that's why I created a foreign key here, so that I can see which major it is when I'm building my query, right? So all you have down here is a description of what's happening up here. Maybe you guys could read it so that you could better understand what's happening. And that's it for this session. As usual, I'll be posting the assignment on Thursday. Make sure you go ahead and do that. And if you have any questions, email me or post a comment. I'll get an email notification for that as well. All of your tables are self-defined, so you have to decide when you'll be using certain things, right? So if you notice this table here, it has a course ID. I didn't create this table. It has a course ID, but I can easily see that this is probably a foreign key because there's no other place that describes what the course is. So there must be a table that does do that, and it must have an ID for each course. Alright? Alright guys, I'll stop here. You guys enjoy the rest of your day, and I'll see you Thursday or whenever you ask questions or comment. Alright, see you guys later.